Welcome back, everybody, to our first symposium. So the way it's going to work is we'll have 3 talks, now and then more general discussion in the last half an hour of the slot. If you have some immediate question on the content of one of the presentations, we can take these immediate technical questions right after the talk. Otherwise, bigger discussion questions, please, save them up for the discussion period at the end. All right, and with this, I would like to hand over to Margrit, our first speaker.
Thank you so much, and thank you so much for having me. The topic of our symposium is individual differences in semantic and pragmatic processing, and because of that, I'm going to talk about the individual differences in the processing of what I call lexical innovation, in the case of denominal verbs. Now, when I say lexical innovation, this actually fits perfectly with Petra Schumacher's plenary talk, because she called this ad hoc metonymy. Okay, so what she referred to as non-conventionalized ad hoc forms is what I'm going to refer to as novel forms of or innovative forms. And this is collaborative work with some colleagues of mine at Cambridge and with Robin Carson from UCL, who happens to be here in the audience. So I hope I represent you well, Robin. Okay, so let's start with an example, because we're looking at a slightly different type of polysemy than Petra discussed in her talk. Namely, we're looking at denominals, nouns that are used as verbs. So instead of looking at, cappuccino here, we're looking at the word cocktail. Linda and Robert throw great dinner parties and always cocktail their guests liberally beforehand. Hopefully you can agree with me that you haven't seen this cocktail used in this way before, or have rarely seen it be used in this way before. Yeah? Okay, great. But hopefully you can still understand it, like you could cappuccino in Petra's examples. Okay, so that's kind of the point here. We're looking at a type of lexical innovation where you can still understand the meaning. You can pragmatically infer what the speaker intended, but you might not have encountered this word used in this context before. Okay, so these are instances of polysemy, a single linguistic expression having multiple related senses, and metonymy, likewise, is an example of polysemy. But here specifically, we're looking at nouns and verbs that look the same, okay? They have the same surface form, and specifically nouns that are being used as verbs. Now, this is a highly productive rule in English, but not in all languages. But things like run, to run, or the run, right? Stone, the stone, to stone. These words can be used as both as nouns and as verbs. Now, this possibility, this highly productive rule of crossing categories allows us as humans to also use these as ad hoc instances or novel instances. Okay? So when I use to cocktail, or when I say I ballooned the front gate, you might still understand what that means, even though you've never heard it before. And importantly, these are sometimes viewed as instances of metonymy, just like Petra Schumacher discussed. But in addition to just changing meaning, so a semantic shift, there's also a syntactic shift, obviously, here, right? So there's a category change. We're taking cocktail, traditionally a noun, and using it as an event, to cocktail. So we're also changing the category here. And these are things that are used so often in daily life. You might not realize it, but once you start studying this experimentally, you see them everywhere, okay? So I'm teaming in from the UK. The airline industry could be coveted for years, okay? They're all things we can understand, but might not have heard before. And this is not a novel thing. So Petra had examples from books already. I have an example from Shakespeare. There are people that did entire studies on denominal verbs just on the basis of Shakespeare, because he was so innovative, right, with his language use. He used, for example, you would companion me as a verb, whereas traditionally that would have been a noun. Okay? Now, the seminal paper on cross-categorial instances, specifically denominal verbs, so nouns used as verbs, was written by Clark and Clark, and they identified 1,300 innovative denominal verbs at the time, okay, 1970s. But importantly, they also proposed a theory of interpretation of these innovative denominal verbs. And hopefully, based on the keynote talk before this, you already agree there has to be some pragmatic inference being made to understand the intended meaning of this expression. Okay? But interestingly, Clark and Clark also listed what they think the process underlying this is essentially from the speaker's perspective. Okay? So the speaker means to denote the kind of situation that he has a good reason to believe that on this occasion the listener can readily compute uniquely on the basis of their mutual knowledge, etc., etc. So I hope you get the point. They don't necessarily use the term pragmatic inference, but I think it's clearly written in here, right? So the listener can readily compute, and on the basis of their mutual knowledge, implying that context and world knowledge is required to understand this denominalization. Okay? Now we get to Robin Carson's work, who more explicitly stated these types of things. Now, we've seen in Petra Schumacher's talk again that some senses can be conventionalized and stored in a lexicon. Here, specifically in my talk, we're looking at instances that are not conventionalized, okay? Like cocktail, that you might not have encountered before. If you haven't encountered a form used in that sense before, logically it has to be pragmatically inferred from context. Okay, it can't just be a simple retrieval process. Okay, so in the example of the cocktail someone, you do have to retrieve something, namely the known noun sense of the word. Of course, you're using the noun sense that you already know. But you use the immediate discourse context, as well as the syntactic environment in this case. Okay, so that was a little bit less necessary maybe for the cappuccino, where a noun was used as a noun, but here a noun is used as a verb, and definitely we need to look at the syntactic environment as well. And then the verb sense can be pragmatically inferred. Okay, so I have a little overview sketch for you here of what that might look like. I made this myself in Paint. I was looking for somebody who had sketched this up before, but actually couldn't find a good example. You can see my mouse. So you have the word form, at least of the noun, stored in your lexicon. What that stored representation looks like, I don't want to get into now because there are different theoretical approaches to that. But let's assume that you have at least, in some way, shape, or form, you have this stored in your lexicon. Now, of course, a dominant meaning, in this case, the noun meaning can just be retrieved, right? It can readily be retrieved. If you say, I would like a cocktail, no problem whatsoever. If there is a subordinate meaning, which is a related meaning but not the dominant meaning, if it's conventionalized, so you've heard it before, or maybe you've adapted through an experimental process of being exposed to it multiple times, you might be able to access this representation directly as well. However, if there is no previous exposure to this word use, okay, so cocktail as a verb, for example, there has to logically be an inference, okay? It's an unconventional, novel, innovative form. And there are several sort of theoretical models that deal with representation and inferences, but luckily, That's not often in the literature. They actually all agree with each other, okay? Karsten and Clark. Nobody's arguing that there isn't a pragmatic inference required to interpret a novel form. Okay, so what we're looking at is still retrieving the dominant meaning of the noun, but then making an inference to understand an unconventional form. This has psycholinguistic implications. Typical polysemous words might see a processing advantage, so they're quicker to process, but obviously for unconventionalized novel ad hoc forms, we would expect there to be a processing cost. But since this is a symposium on individual differences, I want to ask the question, what else is needed to process these novel forms? Now, we went back into the literature and found a quote from Robin Karsten saying that brings with it an emphasis on the considerable flexibility of our capacity to generate and grasp new senses of words in new contexts. Okay, so a certain flexibility. Now, I spoke to her about this in person because as a cognitive linguist, my first thought was cognitive flexibility. And Robin, I think you later admitted you hadn't meant it in that way. But anyway, we interpreted it in that way and sort of ran with it, okay? So just be aware of that. So I'm no longer quoting Karsten from here on out. This is my interpretation of her quote. But as a cognitive linguist, I immediately thought cognitive flexibility might be required. And that wasn't without precedent, okay? So we have no psycholinguistic evidence as of yet on the processing of innovative denominal verbs, okay? I've looked long and hard, I haven't been able to find much, but we know something about other types of pragmatic inferences, such as scalar implicatures, primarily in children. We know that, for example, cognitive abilities or executive functions, such as cognitive flexibility, potentially influence your ability to make pragmatic inferences. And we also know that verbal ability, linguistic knowledge, influences at least children's ability to make pragmatic inferences. And then we have a third factor, which, again, we took the word flexibility and sort of ran with it, but which we'll call linguistic flexibility. Because what we noticed when we did some piloting for our studies was that some people basically just refused to acknowledge that the word cocktail was used as a verb and that they could infer the meaning. So these are some quotes, but basically, you know, you're Americanizing the English language. Why are you doing this? I cannot complete this. This is too annoying, etc., etc. So people were just like, these people were inflexible. Okay, and I don't think that was just a cognitive effect necessarily. It was a certain sort of linguistic rigidity potentially. So our larger research program basically investigates the following questions, which are very general, admittedly. How do individuals process these innovative ad hoc denominal verbs? What's the interaction there between syntax and pragmatics? Because obviously there's a semantic pragmatic effect of the inference of the new meaning, but undeniably there's also syntax involved because you're changing categories, okay? You're shifting categories from a noun to a verb. And what are the sources of individual variation in this process, okay? And we can think about cognitive skills or cognitive flexibility, like I said, linguistic flexibility. We also thought about meaning generation abilities, your ability to generate new meanings and select between those. And then we also looked at general pragmatic difficulties, such as those associated with autism spectrum disorder. Okay, so I'm about halfway through, but this was a theoretical framework. I'll now present some experimental evidence. So I have 4 studies in total, so I'll go through them rather quickly because they didn't give me that much time. But if you have any sort of questions on the technical details after, just let me know. Okay, so the first study was a reading study, web-based, and essentially what we just asked was, can we find evidence of the costs of processing of novel denominal verbs? And what individual differences are involved in this process? Okay, so we had 2 conditions, a noun condition where cocktail is used as as a noun, and then cocktail as in the example you've seen before where it's used as a verb. Okay, and we took sentence reading times because this was a web-based thing, and acceptability judgments. And as additional measures, we had measures of, again, what we call linguistic flexibility, relating to the flexible processing of and use of different of languages in different social contexts. So think about the diversity of an individual's experience. For example, are there multiple languages being used in the community? Is there a prevalence of non-standard accents, and how open are individuals to that? So these two were based on, there was one questionnaire about sort of social linguistic diversity, and there was one verbal guise task where people were asked to sort of rate people with different accents on sort of how educated they sound, how friendly they sound, etc. And that's sort of an indication of how willingly they accept flexible language use. Okay? And then we have the cognitive flexibility as well, which relates to well, your ability to recall information. There's a working memory component as well. There's a divergent thinking and creativity component, but it's really how well you can switch between different situations, representations, etc. And theoretically, cognitive flexibility has been proposed to be involved in the processing of polysemy. And more dominantly and more recently, it's been the focus of a lot of research on language control, so the mechanism that allows you to effectively switch between different languages. Now here, we're not switching between different languages, but we are switching representations, we are encountering new forms, etc. So it's not sort of completely out of the box to think that this might have something to do with the processing. I'll just quickly introduce our cognitive flexibility measures, just so that the speakers after me don't have to do the same thing anymore. We use 3 measures. The first one is a 2-back task. So essentially, we start at the left upper corner. You see a P, you don't do anything. A C, you don't do anything. A D, you still don't do anything. But as soon as the letter is the same as the letter 2 letters back, that's your working memory component right there. As the letter 2 letters back, so the C here is the same as the C here. You press a button, okay? And then the task continues. B, is that the same as D? No, you don't press a button, etc. So there's a working memory component there, but an updating component as well, because every time you have to memorize new letters. We also had a global local task. That is quite a well-known task in the field of autism research. It's about your ability to switch from global representations to local representations. So for example, in the left shape, which is an X made up of X's, well, there's a match, right? If I ask you afterwards, what was the shape of the large shape or the small shapes? X is the correct answer to both. But on the right, you see 2 examples where the large shape and the smaller shapes mismatch, okay? And people show a delay here when they're asked to answer about the more fine-grained information. So they have a tendency to want to say square if the square is made up of little x's, for example. So it's switching in representations again, but in a visual way. And then the last task is called a set shifting task, where you see a shape and you have to match it to 2 other shapes based on color or shape. And I'll just show you an example so that it's clearer. So you essentially see, it's small here, but it says the word color, and then you see a red rectangle, so you're asked to match it by color, so you match it to the red triangle in this case. So you press the left button, not the right button, which is a triangle, but it's not matched, which is a square, but it's not matched on color, right? Because it's blue. And then the next trial, you might get a shape, a color cue again. You get a blue triangle, so you have to match it to the blue rectangle. You can see I'm already getting confused explaining this, which tells you how difficult the task is. Even though it seems like a children's task, I promise you adults struggle, adults make mistakes as well. And then, for example, you're asked to match it on shape instead, so you see a blue triangle, so you have to match it to the red triangle, so you press the left button instead of the right button. Okay, so these are our covariates. our additional measures. You remember we started off with the conditions here, right? Okay, so let me show you the results of those measures of condition. We measured acceptability ratings, and we can see that the noun use logically was more acceptable than the ad hoc verb. And not just that, I just want to emphasize how much variation there is in the ratings here. Okay, so everybody loved the sentences with the nouns, that's great, but there was much more individual variation for us to potentially explain with cognitive abilities or linguistic flexibility here in the verb plot. Reading times for the whole sentence, again, it's less clear on the figure, but there was a significant effect here as well. So people read the sentences with the innovative verbs slower as well. That might not be usually surprising, but let's look at the effects of additional measures. We actually didn't find any effect of our cognitive measures. And we used 3 of them, so we thought we were pretty thorough with including sort of several different types of measures, but we didn't find any correlations. However, we did find effects of our linguistic flexibility tasks. And I don't have much time, so I'm going to focus on the plot here on the left. What we see here is the sentence reading time, plotted on the y-axis, and SILD-Q mean score, that is the contextual individual linguistic diversity of an individual, okay? And you can see that people with high contextual linguistic diversities, i.e. exposed to many types of linguistic input, potentially in different languages, etc., they basically read sentences with the nouns and the verb conditions equally fast, okay? So they weren't really delayed in the innovative verb condition. Whereas people with low contextual linguistic diversity, they were significantly delayed, okay? So there seems to be something there in that being more exposed to linguistic diversity or being more linguistically flexible allows you to actually process these innovative forms faster. However, this was at a full sentence level. That's not very fine-grained, admittedly. So in the second study, we looked at ERP measures, okay? And what we wanted to know is, can we find evidence that this is really a pragmatic and a semantic rather than a syntactic process? Because again, all of these things are clearly involved in the processing of innovative denominal forms. Okay, there are some predictions here. I didn't even want to call them hypotheses because I think that is too strong when you really don't really know what you're looking for. So I've just listed some options, and these will be in line with what Petra Schumacher presented as well. So there's one previous study that looked at Shakespearean expressions, which found left anterior negativity and a P600 effect of syntactic violation for denominals. Then there's, of course, the late positivity that Petra Schumacher presented on that represent inferencing and updating. Schumacher also found an N400 effect representing semantic surprisal. And then option 4 would be no late positivity, but actually a late negativity, which has been found to reflect semantic integration and pragmatic processing. So again, I don't want to call these hypotheses. I think that's too strong, but we can go either way. And this is what we found. This is a grand average, and I'm just plotting in red the innovative denominal verbs and in black the nouns. And I think what we can see quite clearly here from around 400 milliseconds on until around 800 milliseconds is that there's a sustained negative effect, actually, rather than a positive effect of denominals. Now, these are not the same as the noun-noun metonymy that Schumacher represented, because there is a category shift involved. But we still want to look further into what this actually means. Now, as for the covariates, we had covariates here as well, linguistic and cognitive. These are preliminary results, and the plot is a little bit difficult to read, so I'll walk you through it. but we may have found an effect of cognitive abilities here. This is a topo plot because what we did is, and I think that's different from the previous presentation, we actually analyzed all of these curves over time. Okay, and then looked at where the differences lie over time. And that means if you get an interaction with for example, NBAC performance in this case, which is called A prime score, it's essentially three-dimensional. So that's why it's so difficult to sort of represent in a simple plot. But essentially what you can see is higher A prime scores is better performance on that task where you had to identify the letter 2 letters back. Over time and with the voltage of the ERPs, okay? And what we can see is that in red in the right bottom, we see sort of more, higher values, which is more positivity, with lower A prime scores, okay? So it seems that this sustained negativity is more present in individuals with higher updating and cognitive flexibility scores. However, this is very preliminary, so let's look at our next study to see if we can draw some more conclusions. Okay, just to summarize for you, because I know this is a lot of information. We did find evidence for a cost of processing the nominal verbs, and I put monolingual individuals between quotes because we're looking at linguistic diversity, i.e. being exposed to multiple languages in your daily life. So all of these individuals who claim to be monolingual still showed an effect of linguistic flexibility in the processing of the nominal verbs, but we didn't find any influence of cognitive abilities in study 1. In study 2, we found sort of a broadly distributed sustained negativity, which may reflect semantic integration difficulties. However, you could also interpret this as a left anterior negativity, which is a syntactic component. So actually, we thought we would get more fine-grained measures based on these ERPs, but actually we still think they can be interpreted in multiple ways. So that's a little bit up for debate. And we found possible relations with cognitive abilities in online processing, which is a little bit more sensitive to the full sentence processing we looked at before. Okay. In study 3, we sort of went back to the drawing board and said, okay, any of these ERP effects that we found, couldn't they just be due to unexpectedness, right? If this is an N400 associated with semantic surprisal, isn't that just what we're seeing and not all of the complex things that we're inferring that these effects mean? So we went back to the drawing board and ran an eye tracking experiment with 3 conditions, and now instead of comparing nouns to verbs, we're comparing verbs to verbs. Okay, so we have expected conventional verbs, unexpected conventional verbs, which means they're unexpected in a sentence context, but they're very conventional in their use in English, and our novel denominal verbs again. Okay, so an example would be, at their dinner parties, Linda and Robert always thoroughly entertain their guests is the expected one, delight their guests is the unexpected, and cocktail their guests is the innovative one. Okay, so I hope these conditions are clear. As for additional measures, we now looked at meaning generation abilities as well with an alternate use task, which is essentially, this is a brick, tell me all the unusual, creative, uncommon uses that you can think of for a brick, okay? And we looked at linguistic flexibility measures again because we were successful with those in previous studies. Okay. And we also measured acceptability judgments of the sentences again. And these are the acceptability judgments. And so now we have 3 conditions, right? The expected verbs were actually judged as more acceptable than the unexpected verbs, but they were both judged as far more acceptable than the denominals. Okay, so we do see an effect again. And again, there's huge individual variation here, as you can see. In the reading time, so this is a very complex plot. It's because it's eye tracking. There are multiple measures, but let me just summarize it for you. In first fixation, so earlier measures of eye tracking, and you don't need to understand the fine-grained detail, but in earlier measures, we see an effect of We call it unexpectedness, so the unexpected verb versus the expected verb, but no additional effective denomalization. We only see that effect all the way on the right in the total reading time, okay? So this seems to be indicating that, well, late effects, early effects would be expected if you're looking at sort of an effect of unexpectedness. Late effects can be more easily tied to sort of inferencing, pragmatic processing, etc. So there does seem to be some evidence of an actual pragmatic process being involved, and it not just being that the denominals are unexpected. In this study, we found no correlation actually with meaning generation ability or linguistic flexibility. So we weren't able to replicate the effects of linguistic flexibility here. So that's just something to keep in mind. Okay, now a final study, because I'm running out of time. We wanted to look at autistic individuals because we know that they struggle with pragmatic processing in general, okay? Taking the perspective of another individual, having sort of expected, socially expected communication, etc., is typically difficult for individuals with autism. So we looked at diagnosis, and we have two groups, people with and without autism based on their diagnosis, and we also ran sort of a questionnaire. This is called the social responsiveness scale, but you can take any sort of pragmatic ability questionnaire. And we indeed see that the individuals with autism here in red score much higher on their pragmatic problems than the sort of bluish group on the left. Okay, so this is just to show you they do differ in pragmatic abilities on a questionnaire. How about on our task? Let me show you the typically developing individuals on the right first. So these are acceptable age judgments again. Typically developing individuals process this is the expected conventional form. So entertain your guests. They rate them very high. The unexpected but still conventional form, so delight your guests, a bit lower. And the unexpected, unconventional, that's the nominal verb, as lower again. Okay, so this is the sort of the pattern we've been seeing all along. I know it's tilted sideways because my postdoc plotted this for me, but I hope you still understand that it's showing the same picture. And again, we see huge variability, okay? That's across items, but also across individuals for these denominal forms. And then we looked at the individuals with autism, and actually they perform really, really well. This was not what I expected to find at all. Now, these results are preliminary, and we do need to do some more sort of pre-processing. But what we can see is that they follow exactly the same patterns, okay, as the typically developing individuals. They can distinguish between the expected and the unexpected verb forms, and they can identify the denominals, and they don't like them. But they don't like them to the same extent as typically developing individuals. Okay, so just to summarize these last two studies, we found some evidence for an effect of denomalization beyond expectedness, but no effect of additional measures in study 3, so no effect of meaning generation abilities and no additional effect of linguistic flexibility. And in study 4, we looked at the individuals with autism, and we found no effect on denomalization abilities. However, this is in a high-functioning, highly verbal subpopulation of autistic individuals, okay? So it's just something to keep in mind. And further analyses of this study are ongoing. So what I hope I've been able to convince you of is that denominal verbs, especially the novel ones, they do presuppose a knowledge of English syntax and the productive rule in English that you can use nouns as verbs. But they also require pragmatics, okay, to infer the range of possible interpretations, and including the metaphorical ones, and then to select that down to the most pragmatically plausible one. Okay, when we look at individual differences, we've seen some evidence for an influence of linguistic flexibility and cognitive abilities, but not consistently so across studies. So I think this is really something that needs replication, and that shows why replication is so important in research. no evidence of meaning generation influence, and a lot of between participant variability, right? So that is the only thing we consistently found, is a lot of variability in individuals' interpretations of denominal verbs. And we feel like that individual variation is largely actually still unexplained. Okay, in our next steps, we're going to look at the acquisition of denominals by children. And I think we should also look more closely at the relation to other verbal pragmatic skills, for example, implicatures, which I think the next two talks are going to tell you more about, probably. So, thank you very much. Are there any sort of immediate questions about sort of the comprehension of the materials? Ah, okay, that's a very good question. So how did they indicate acceptability? That was just an acceptability judgment scale. How acceptable do you think the sentence is? I also ran a pretest where we asked how difficult is the sentence to process, how sensical is the sentence for you, etc. How familiar are you with this use of the word? But yeah, so it's a scale from 1 to 7 in which they just tick a box, yeah. In the back there? So that's a very good question. So did we screen our participants? In the autism task, yes, actually, we have verbal ability, we have nonverbal ability, and we're going to correlate with that as well. In the other studies, no, these were just drawn from sort of the neurotypical population. We can look at sort of educational level, but they were all pretty highly educated. Some studies were done with Cambridge University students only, so I assume they're pretty highly verbal. Yeah. Okay. Thank you so much. I think we'll hand over to the next speaker. Thank you.
All right. Okay, so I would like to talk about some experimental evidence and also computational modeling that we've recently done on individual differences in pragmatic processing. So, you know, Greichen pragmatics holds that inference during communication is regarded as a form of rational domain general reasoning about the intentions of other agents. But in experimental pragmatics, we also find that not everybody kind of behaves as the Greichen optimal reasoner in deriving, you know, all of the possible pragmatic inferences. In particular, you know, it seems that there can be different groups of participants where some behave more like literal listeners, others kind of do derive the expected pragmatic implicatures. And in some settings also, we can see that for more kind of ad hoc tasks or particularized implicatures, reasoning about the conversational participant partner, that this may require several rounds of interaction with this person in order to, you know, show the Greichen predicted behavior. And so what we are currently doing is to look more into individual differences to better understand, you know, what may be the underlying factors into whether somebody will process pragmatic inference, you know, in the pragmatic way or rather in a more literal sense. And today I want to talk about two sets of studies. First of them about individual differences in pragmatic reference games, and second one about adapting pragmatic inferences also to the person that you're speaking to. So in this first study, this is in collaboration with Alexandra Main and John Duff. And here we've been looking at reference games, which are, you know, a popular paradigm for studying pragmatics. So here you can see a listener and a speaker in some toy context, basically. And the speaker is uttering, in this case, triangle. And the listener's task is to figure out which one it is. All right, now our listener could do different things, right? So a very literal listener may say, okay, there's 3 triangles here. I don't know which one you mean, and just pick at random among these. All right. A slightly more sophisticated listener may reason about a literal speaker. So think about, how many different choices were there from the point of view of the speaker to refer to a certain object. And here, in the case of the blue spotted triangle, you could say triangle blue or spotted, right? Under the assumption that you can convey only this short message. So you have more choices than for the other 2 triangles. So, in this case, the speaker would pick among these. Or our kind of proper Greichen listener would reason about a speaker who also reasons about a listener. And they would say, okay, for the other triangles, there would have been unambiguous ways of referring to them. So the speaker would infer that triangle refers to the green triangle. So what one can do, and this is a task designed by Franke and Deg in 2016, is to set up an experiment that has different types of trials in it, such that some of them are trivial, like they can be resolved whatever your reasoning strategy is, so by the literal first order or second order listener. Some simple ones which can be solved not by the literal, but by the first and second order listener, or complex ones for which you really need the second order reasoning. And what Franke and Degen found in their study was that their participants actually clustered into these 3 clusters that you can see here, with some of them that can resolve both the complex and the simple trials, some that can only resolve the simple trials, and some that can only solve the ambiguous trials, so nicely following the theoretical prediction. Now, we thought it was very interesting to find these 3 groups, and then the question would be, why does some individual fall into a certain group? Okay, so what we did is, firstly, we replicated this with a lot more participants. And slightly sorry about the complexity of this graph, but what it does is it shows in colors the different groups of participants that we can find in a data-driven way from our data of people who behave similarly. And then in the shapes, you can see, we asked these participants to also explain their reasoning strategies to us for some examples. So we actually have some insights from what they told us about how they reasoned. Okay, so now you would expect these to coincide, right? So that we get a lot of blue triangles, basically, right? Where people did the proper pragmatic Greichen reasoning, and also in answer to why they chose it, gave an answer that's consistent with this reasoning, right? And you can see that largely, these colors and shapes are consistent with one another, but, in this experiment, we also had a bunch of people who kind of misunderstood the instructions or used some other tasks, such as when you say triangles, you mean things that are not triangles and things like that, right? Which you can also see here, but which don't behave according to any of these, theoretically posited comprehenders. Okay, so this is a first step, right? So here we have quite a large data set of people where we now know how they interpret these instances. And the second question that we're wondering about is, how can we relate this to individual differences? So from previous research, this mostly holds that this should be related to the depth of reasoning. So, and it has been proposed that working memory capacity may play a role here via the theory of mind components. So comprehenders have to track speakers' epistemic state in order to reason that they, what they intend to say. And this may require certain, amount of working memory in addition to the theory of mind abilities. And secondly, that this may be related to theory of mind skills, for instance, assessed by things or correlating with things like autism spectrum quotient, such that pragmatic participants may, differ in how strongly they show such effects. So in our study, we collected several individual difference measures from the same participants for which we have elicited the pragmatic behavior. And we collected information about their working memory capacity using the operation span and the backward digit span tests. We tried to assess their theory of mind abilities from the reading the mind in the eyes test and the short stories test, and their reasoning abilities through the Raven's progressive matrices and the cognitive reflection test. I now don't have a lot of time to go through all of these tests in detail, but I would like to focus on the reasoning tests, the Raven's progressive matrices, because it will be particularly relevant for understanding the results that we found. So the Raven's matrices test you may have encountered before, right? So here the idea is that you have this grid of shapes, one of them is missing, and the task is for you to determine which of these shapes is the one that should be filled into the space. And in order to be successful in this task, it requires to have an efficient pattern induction mechanism, basically, in order to navigate this hypothesis space and identify which one is the right shape here. Okay, so what we found in our study is that there was a significant effect of reasoning abilities as assessed by this Raven's progressive matrices task and the performance, like the literal versus pragmatic reasoning task. So what you can see here on the x-axis is essentially the score that participants had according to the reasoning test. And you can see that those people who score higher on reasoning do have a larger proportion of correct answers, both in the simple and the complex trials, than the people who scored lower on the reasoning test. We also found an effect of theory of mind abilities. So here again, you can see that for the people on the higher end, here of the x-axis, they have a better performance on the pragmatic task. This is an experiment that we ran in with slightly different items several times. So in our other two replications, we also found effects of reasoning. So this reasoning effect seems to be very stable. So we were then wondering, why should there be, exactly this correlation with the Raven's progressive matrices and the pragmatic task? And we decided to look into cognitive models. So in particular, there's a cognitive model of the Raven's progressive matrices task by Stockwell et al. 2021. So here they say that the performance on the Raven's matrices is dependent on activity in the basal ganglia. And in particular that it can be parameterized based on the reinforcement learning abilities of individuals. So essentially, as long as you haven't run out of patience on this task, right? You're trying to have try different hypotheses about what might fit in the space. And whenever you try a hypothesis and find that, oh, this doesn't quite fit, right, there's kind of negative reinforcement learning feedback, basically. So, downweighing this strategy for finding the correct pattern. And over time, if you can effectively inhibit this strategy, you will not try it again, and you will be faster and more effective in solving this task. So what you can see here basically is the effect of the negative feedback strength and of persistence, like so for how long do you try before you give up and just guess some solution. And you can see that, for both of these, higher persistence or higher negative feedback strength would be correlated with better performance on the Raven's matrices task. All right, so now how do we take this to the pragmatics task? So this is a depiction of our ACT-R model of the pragmatic task. So let me guide you through it. So here in the beginning, participants would always, try a very easy strategy, right? That's always the easiest to try first. When you hear triangle, you check, is there a triangle? And then, if this one is successful, then you don't have to engage in deeper reasoning, right? So always start out with this default strategy. Now, you can see that this leads to this box, check each referent for match. Now, if there's exactly one matching referent, there's just one triangle, then you're done basically, right? So you can immediately respond. If not, then you may either have run out of patience already, in which case you just guess and may give a wrong answer, right? Or you may engage in trying a different strategy for solving this task. All right, so and here in our model, we can sample from the more sophisticated reasoning strategies. So that would be the strategy that reasons about the speaker, or the strategy that does the proper Gaussian reasoning about the speaker who reasons about the listener. Okay, these strategies are slightly more costly, right, because they involve more steps. And with each of these strategies, you would try them again, wonder, could I now resolve this? If yes, you respond. If no, if you haven't run out of patience, you run another round of this. Now, over time, if people have a good kind of negative reinforcement learning feedback signal, they will assign lower probability to the very simple strategies, because those strategies will be often not successful, right? So, and they assign higher and higher probability to the pragmatic strategy. So, for people with higher reinforcement negative feedback, or with higher patience, we will expect them to more effectively learn to try the complex strategy, which is always successful for the stimuli. Okay, so now what you can see here on top, basically, I'm showing here, I hope you can see this, the simple and complex trials. On the x-axis, we have the reasoning ability of participants as per the Raven's matrices task, and the kind of red orangish lines, they are associated to the theory of mind abilities, because remember, both of these used to be significant predictors of task performance. Now, in the model, I just explained to you how we implemented this reasoning ability in terms of the FNEG, this reinforcement feedback. What I haven't explained yet is, how we're approximating the theory of mind ability scores here. And the way in which we're doing it is by assigning different initial probabilities to the different strategies, right? So we would say that, for a person with low theory of mind abilities, like the most complex pragmatic strategies would just have a lower prior probability of being sampled in this process. And when you do this, you can see that our model shows patterns that are quite similar to what we actually see in the experiment. In addition, one nice thing about this ACT-R model is that it makes predictions as well about other things. So, for instance, about how people learn throughout the task, right, from early to late trials. And it also makes predictions about reaction times. So, for instance, that people take longer to give correct responses than to give incorrect responses, because incorrect responses may be the result of having run out of patience and just guessing among the alternatives. And those, are predictions that we were able to verify also with our empirical data. So next, I would like to move to another study that relates this to a different task. So this is not the reference game task, but a different task on looking at atypicality inferences. This is a type of pragmatic inference that we've been working on for a little while. So here, in a nutshell, we have a speaker who says Paul went shopping, he paid the cashier. And then some people here draw the inference that, oh, if this is mentioned, well, paying the cashier is something that would be normally assumed to happen, but if it's mentioned, then it must be something special about Paul. Maybe he doesn't usually pay and so on, okay? So this inference is something that we have validated in various experiments. So what you can see here is the full version of an example stimulus in green here. And what we ask people is, how often do you think Mary usually eats when going to a restaurant? They have to answer on the scale using the slider. And they may have to answer this question in the case when no informationally redundant utterance was mentioned. So, they just hear about going to the restaurant or just hear about going shopping, right? Or in the case with redundancy, this is when, she ate in the restaurant or he paid the cashier is mentioned. And now what you can see is that when the informationally redundant utterance is present, people are more likely to give a lower rating on this typically happening, right? So this is the atypicality inference. That's worth mentioning because it's not typical for this individual, but you can also see in this graph here, right, that there's quite a lot of variability, right? So in the population, we find this effect, but there are some people who do not, react basically due to this informationally redundant utterance. And so in this study, we're also wondering, what are individual differences that may correlate with this? And we again collected data from people on this task, as well as an individual difference battery, including again the Raven's progressive matrices test, cognitive reflection test as proxies for reasoning abilities, autism spectrum quotient, working memory capacity, and literacy, because this is more linguistic task than the previous one. And we again found a correlation with these Raven's progressive matrices performances. So on this task here, I showed you these results before. I'm now, moving this around slightly to show you the effect. So in this case here, the left panel corresponds to the gray result bar, and the right panel with informationally redundant utterance to the black one, right? And what you can now see in these panels in addition is how people differ by reasoning scores, right? On the x-axis, you can see, poorer versus stronger reasoning abilities. And now here, on this end, basically are the people with high performance on the Raven's progressive matrices, and you can see that they show a very large atypicality inference effect, right? Corresponding to, a larger effect than what we see across the whole population, which is summarized in the black bar. Whereas the people with lower reasoning abilities, according to Raven's matrices, they barely have this effect at all. So we think that, it's interesting, basically, that across these slightly different pragmatic tasks, we can nevertheless find a consistent effect of correlation with the Raven's matrices performance. And, we would like to extend also our ACT-R model to explain this task in terms of, selection between different strategies for dealing with the informational redundancy here. I mentioned that we ran a bunch of other individual difference tests here as well. We also found a marginal effect of autism spectrum quotient, but it was an unexpected direction, so not very consistent findings compared to the other study. We did not find effects of working memory capacity, And, in terms of literacy, we only found domain effect, but not an effect of the strength of the atypicality inference. So my intermediary conclusions at this point are that pragmatic inferences in reference games and atypicality inferences correlate with reasoning abilities as measured in the Raven's matrices. For theory of mind or autism quotient, we had a bit of more mixed results, like these across the different replications of the studies did not always hold, and in the case of the last study, it also didn't go in the expected direction. And we did not find effects of working memory capacity. All right, and this mechanistic model of using ACT-R kind of gave us kind of an interesting, analogy basically for how to think about the process of pragmatic reasoning in this case. And we saw that it can also predict individual difference in terms of the accuracy in response times and adaptation during the experiment. And this last aspect here of adaptation during the experiment is something that I would also like to focus a bit more on in the last part of my talk. So this is a study done together with Sebastian Schuster and Alexander Main on adapting inferences to specific speakers. So pragmatic inferences don't only, also depend on who you're talking to, right? If you're talking to a child or interpreting what a child is saying, your inferences may be different from when an adult has said it or when it's a native or non-native speakers and so on. Such effects have been shown. And in some work by Schuster and Degen, they showed that, what inferences you draw would also depend on your previous experience with that speaker. So this study here focuses on quantity expressions like, certainty expressions, like might and probably. And what you can see here is, in this graph, is that, for events that have a probability of 40 or 50%, people would be more likely to say might, and for higher probabilities, 70, 80%, they would be more likely to say probably. Now, as a listener, you might encounter speakers that differ in their usage of these expressions, right? So some speakers may be more optimistic or more, generous with using the word probably. And in a situation, where there's probability of 50% of something happening, one speaker may say might, another speaker may say probably, for instance. Now, if you have a lot of experience with such a speaker as the listener, you may adjust your interpretation of next time that they say probably, how likely that event actually is. So now here you would have speaker-specific expectations, right? Where, for one speaker, the use of an expression would be associated with different probabilities. Now, in the experimental paradigm that we used here, it's an adaptation experiment. So here you can see the little girl and the bubblegum machine. And she says, I want a blue one. And now the interesting thing here is that our speaker, maybe one of two different speakers. So the cautious speaker, among the different trials that we have here, will have 10 exposures where they use might, in the case where there's 60% blue gums. Whereas our confident speaker, in the same situation, would use probably. Okay, so in the exposure phase, people just watch this and they see that, we have two different identities of speaker here. So it's two different photos basically that come in here. They might associate then the different expressions in these situations with the different speakers. And then in a post-exposure test phase, we essentially ask them, given the speaker and the situation, what do you think, bid on basically what the person would be saying as a way to assess what people believe about the use of this person's certainty expressions. And what we can see here firstly is that indeed people kind of have learned from the exposure phase. They do adjust their estimates of what a person will say based on how they've seen them use these expressions in the past. So we're replicating the overall speaker adaptation effect. But if we now look into this in more detail, we can actually see that there's also variance in this population of participants, right? So we can see here in red those people that show strong adaptation effects, and in the different shades, you know, blue and green here, people who actually do not adapt. They stick with their original preferences. Okay. So now we were interested in, you know, what is driving also these individual differences between some people kind of adapting and other people not doing this. And we found, you know, like we tried different individual differences tests. And particularly relevant here is the keep track task, which is a task of working memory updating. So here you should remember the last item of certain categories. So for instance, a category could be animal or countries or so, right? And so then you see giraffe, Brazil, lion, and so on. And at some point, you know, you're asked to say, like, you know, what was the last item from the animals. So you're constantly, you know, having to categorize and then overwrite, you know, what was the last one. And what I'm showing here is the individual difference results. So we find a correlation with performance on the KTT, so this keep track task, with, you know, people updating their expectations about the certainty expression use of the speaker, whereas we did not find this for any of the other individual difference measures that we tried. So only the keep track task performance predicts the extent of adaptation. And we also replicated this in a study with 91 participants. I'm just sorry that now the color use is slightly different. So the purple here used to be red on the previous slide. But it, you know, successfully replicated this correlation. So as I'm running out of time, basically what I want to say here is that the keep track task correlated well with the speaker adaptation, but we're a little bit unsure, right? Keep track task, it has a component of working memory capacity and of working memory updating, so it's a bit hard to tell which of these components it is. And maybe speeding through the last study here, we have a different study, a study with a different task, where we have one person, one speaker that tends to make jokes, another one who doesn't tend to make jokes. And with a similar logic as the previous experiment, we can observe that people learn this in the exposure phase, and we can again find a correlation with the keep track task performance. So those people who perform better on the keep track task are also the ones that successfully predict whether some completion should be associated with a specific person. So the variation in pragmatic inferences we found is affected by reasoning abilities. The theory of mind abilities, we had a bit more mixed results, and for working memory updating, one thing that I forgot to say here is that we had in this study, in addition, just a working memory capacity measure, which did not correlate with the results. So we believe it's the working memory updating component that is particularly relevant here. So the ability to quickly adapt these beliefs during the interaction. So methodological remarks, we sometimes, struggle to identify the different individual difference tests and, decide, which ones to use to capture a specific construct. There's a lot of variability also in the previous literature as to what people use, for instance, to capture theory of mind abilities. And as a second remark, the cognitive modeling experiment here helped us a lot with respect to, shaping a way in which, mechanistically there might be a cause, same process basically that can relate what we find in the individual difference task performance and the target task performance. All right, so with this, thanks for your attention. I can take some questions. Mm-hmm. Yeah. Yes, yes. We try to measure it, yes, because we have some, post hoc questions basically where we ask people to tell us, what their inferences were, because we're, just as you say, right? You can also conclude that the speaker is not very rational and so on. So in this case, yes, we do have some additional information about the actual inferences that they took. Mm-hmm. Yeah, I mean, I think it's probably a bit of a mixture, right? Like, with this autism component here, right, we were already saying that, people may like different strategies more or be more used to using them and so on, right? And select them with different probabilities. In our model, we don't have a kind of a way of saying where the strategies come from, how they're learned. But we also think that we can see during experiments that people actually adapt their strategies, right, to the success that they experience during the experiment, right? So I think it would not be very consistent, basically, to say like, oh, a person always has this in this strategy, right? Because it's a rational choice, right? Like how much energy or, thinking to expend. All right, so I think it's time to move on to our third speaker, and then we can discuss more generally afterwards.
My name is Maria Stachalska, and I'm happy to be here. And I will actually continue on what was the last points of Vera's talk, so on strategies. And it will be maybe a little bit different view on the individual differences, because I'm afraid I will present mostly negative results on the correlation with various personality or cognitive traits. Okay, so what we are addressing here is a question of whether language processing is universal across population. And we have an assumption of a shared cognitive architecture on the one hand, and on the other hand, we have large variability among individuals, which is reflected in, for instance, different rates of deriving pragmatic inferences, such as implicatures, easiness in interpreting metaphors, irony or indirect requests. And people were interested in which individual differences play a role underlying this variability. Here, considering dimensions such as cognitive traits, so working memory, executive control, or personality traits, and especially the often mentioned already autistic spectrum quotient has been considered a correlate of pragmatic language skills. This variability may be also experience-driven, but also reflect the role of selective attention or simply individual strategies that may be guided by task demands or basic strategic choices of individual. And that's what I will more focus today on. A small interlude leading to actually pragmatic inferences. So At the group of Valentina Bambini, they have developed even a tool for assessing variability in pragmatic competence, which is basically a test where people can, where people's skills in various pragmatic aspects of language are measured, and this allows to attest the pragmatic competence in both neurotypical and clinical populations. And certain pragmatic phenomena are specially believed to involve theory of mind, like processes, for instance, especially irony, so more complex pragmatic inferences. And pragmatic difficulties have been linked to theory of mind deficits directly. However, with some types of implicatures, such as generalized, especially scalar implicatures, this has been more puzzling. So since there has been the famous paper by Mant and Newland that also Vera mentioned, showing an effect of autistic spectrum quotient communication subscale, so not the total score, but the specific subscale for the processing of scalar implicature. This was an ERP study where they showed that people who were higher on the scale, so they believed to have lower communication skills, they had a more flat and 400 response for the violation of implicature in, under informative sentences, such as some people have lungs. However, since then, I am not actually, perhaps I'm wrong, but I am not aware of a successful replication of this effect. So we have tried to replicate it in a sentence picture verification paradigm. So of course, it was a different type, a little bit different type of experiments, different task. But we also tried to see a relation between autistic spectrum quotient and ERP responses associated with the violation of scalar implicatures. We haven't found it. We also tested working memory, digit span, and rigid span, and actually a matrix reasoning test from a different battery, but similar to the Raven matrix reasoning test. We didn't find an effect. This was also not the case in study on implicatures linked to numerical expressions, as well as a study on implicatures in context where the speaker knowledge has to be considered. So something that is presumably should involve more of epistemic or theory of mind-like reasoning. So these generalized or scalar implicatures, where we do deal with the two possible interpretations, so a logical interpretation and a pragmatic that is reflecting the derivation of the implicature, may be a matter of more strategic choice of individual speakers, at least in highly constrained experimental contexts where a sentence picture paradigm is involved. While this behavioral choice of the interpretation was in our studies a strict predictor of the ERP effects, there was no correlation with the measures we have collected. So the question arises, perhaps it's a matter of ad hoc decision of the individual in a specific situation of the day. But it doesn't seem so. So there is a high correlation between the choice of interpretation when you give a similar task to the same individuals on two different occasions that can be weeks apart. So in this latest study where we had a scalar implicature task that involved a speaker, in the first experiment we had a randomly selected population of participants. And in this specific task, we had a low rate of implicatures derived. Only 25% of participants derived the implicature, so 75% did not. So in the second experiment, we have pre-screened the participants by giving them an online questionnaire first, which contained a similar task. And we only invited to the lab people who previously responded pragmatically in the online questionnaire. And then in the lab, actually the rate dropped of those people who do not derive the implicature to 28%, so from 75 to 28. So it's a significant drop. Of course, some people changed mind, but people stayed mostly consistent with the interpretation they have chosen in a similar task maybe a few weeks earlier. And they were not aware that that's what we are actually looking for. So it's not just a mood of the day. So there is people have some preference for the pragmatic interpretation or not. And this reflects some individual variability, but it's sometimes hard to find correlates with other types of cognitive or personality traits we can test. This kind of individual strategies play a role in pragmatic processing. However, in these studies previously I mentioned, we always had a behavioral correlate within the experiment. So let's say people have a true value judgment task and they respond to under informative sentences that they are true or false, and then we see this reflected in their ERP responses. So you could say that the ERP responses correlate basically with the behavioral judgment they give in the experiment rather with the interpretation itself. Here I want to present a study from a kind of different area, so on negation and prediction. And here I want to present how individual strategies which are reported post hoc the experiment, so people just say what they were doing mentally during the experiment, how these strategies play a role in the way they process the given linguistic task and are high correlates of the recorded ERPs. So we don't have a clear behavioral marker within the experiment, but we have variable strategies that are reported post hoc that lead to differential processing patterns. Since it's a new paradigm, I do have to explain you a little bit more on the background of the experiment we were doing. Predictive processing is a key aspect of human cognition. It's also relevant for language comprehension. And the question we ask is to what extent and at which processing stage the presence of alternatives that can be contextually available modulates the prediction for the upcoming word, and specifically how this prediction is modulated by the use of negation. And here we also take N400 as a marker of meaning-related prediction error, and I am happy that Petra's keynote was just before, because I don't have to now explain all the details about ERPs. And why negation is relevant in this aspect? That is because for a long time, negation has posed a challenge in the psycholinguistic literature. So it was challenging to provide a cognitively plausible model that would not assume that negation is somehow an exception for incremental language processing. So there are these famous results on truth by polarity interaction, and in ERP literature, more specifically, the so-called negation blind N400 effect, where the ERPs recorded for sentence critical nouns reflect the lexical semantic relation between that noun to the preceding phrase and are not modified by the use of negation, even though negation changes the semantic value and more specifically the truth value of the sentence. So for a robin is a tree versus a robin with a bird, we would have a higher N400 because of course robin is not a tree, so saying that robin is a tree is unexpected. But then we can use a negation, so now a robin is not a tree is a true sentence, and a robin is not a bird is a false sentence, but the N400 doesn't reverse accordingly to reflect the truth value or semantic value of the sentence, but it stays the same as for the affirmative sentences. Other studies have shown facilitation of negation processing by context. So if you give a context that pragmatically licenses the use of negation, then you may have the attenuation of this interaction effect. So for negative sentences, you can see a similar pattern of processing, but these results were not like fully showing the reversal of the effect, but more like an attenuation. This leads to the question of predictability. So of course, if you introduce context, specifically context that licenses the use of negation, and this increases the predictability of the words that are used within the sentence. When you think about isolated negative and affirmative sentences, one could argue that negative sentences are slightly less predictable. So they while affirmative sentence tells you specifically what is the case in the word, the negative sentence doesn't specify what is the case. It only says that what is not taking place. So there are multiple alternative scenarios that can be actually taking place. For a sentence fragment such as a rose is, you can find multiple highly predictable continuations, so high close probability continuations. You immediately think of something, a rose is a flower, a rose is spiky, or perhaps red. That's a typical association. Whereas a rose is not. Here there are many continuations that render the sentence true, but not necessarily many that are highly predictable or of high close probability. So rose is not a bird, rose is not an orchid. So this is from the set of similar alternatives. Already in Newland's paper, it has been shown that modulating these close probability values plays a significant role. So here, this so-called Fischler effect was only observed when negative sentences had target words of low close probability values, but it disappeared, was attenuated with increased close probability values. So in this series of studies, we wanted to compare the processing of affirmative and negative sentences in contexts that are high and low, predictable, but are made logically equivalent in the two polarity cases. We had a hypothesis that with comparable predictability, we would observe similar processing patterns, so specifically false versus true and 400 effect that would be both for negative and affirmative sentences. So in low predictable context, we expected perhaps a reduction of this effect. And additionally, as in our prior studies on implicatures, we collected the cognitive and other values such as ACUS, autistic spectrum quotient, working memory digit span, and reading span. And additionally, in experiment 1, there was also a matrix reasoning test, but we haven't done it in the experiment 2 and 3. So the paradigm. So the experiment had a form of a sentence picture paradigm where people were evaluating sentences that described moves in a game of a presumed virtual player introduced by a cartoon avatar like this. This is Anna. And then I will explain it in a more abstract manner. So imagine that Anna has 3 cards. They are just marked here as A, B, and C. And her task is to select some cards while rejecting other cards simultaneously. So there is always, at the end of the round, a binary set of cards. She keeps some and rejects some. So she can, if she has 3 cards, she will keep 2, let's say, and reject 1, or keep 1 and reject 2. You can mark it in various ways. So we went for the marking like this, that the cards that are marked in green are selected, and then the remaining one is rejected. This highlights the selected cards. But if we mark the card in red, then this one is rejected, and the remaining A, B are selected. So these are equivalent scenarios with 2 different variants of how you can mark it. So whether the rejected or selected are highlighted with a frame. So this is to control if the frame somehow attracts your attention to those cards. So this upper panel represents scenarios where you have 2 alternatives for an affirmative sentence fragment to continue. Anna has selected A, but also B, yes? And in the lower, you have only unique target that can be mentioned in a true alternative sentence, namely A. And again, in the upper panel, you have unique target that can be mentioned in a negative sentence about what has not been selected. Anna has not selected C. And this is equivalent in the two scenarios, whereas in the lower panel, you have an alternative for a negative sentence. So Anna has not selected B, but Anna also has not selected C. So you have two alternatives. So we call scenarios where there is a unique target to be mentioned in a true sentence strongly constraining. So this is the high predictable, and those where there are multiple ones weakly constraining. These are the low predictable contexts. So the hypothesis was that for true sentences, there should be N400 for low predictable, weakly constraining versus high predictable context, both sentence polarities. This effect should be reversed for false sentences because if you mention the only object or one of the two objects that does not render the sentence true, then you are violating prediction. So now if you are violating a strong prediction, you should have a higher N400 than when you are violating weak prediction. And then, of course, we wanted to look for false versus true N400 effect and how this truth by polarity interaction works in this paradigm. So we basically expected that it should be a same type of effect for both sentence polarity, especially in strongly predictable contexts, and perhaps a reduction in weakly predictable contexts, weakly constraining. So people, after the avatar was introduced, they saw the set of cards. These were not A, B, and C. They were different objects presented. Then the action was marked, and then the sentence was presented, and finally they gave a true value judgment. They said true or false. So there were 8 conditions. There were negative and affirmative sentences, strongly and weakly constraining contexts, and true or false. This table represents all the possible conditions from the experiments. So as I mentioned, we did 3 experiments, but the variation was minimal, so I will very briefly say it. So in experiment 1, we focused on the context effect in true sentences. So we used false sentences as fillers, and we had also a variability of other fillers. And we introduced this framing variant as a between subject factor to control whether this highlighting cards plays a significant role for the observed ERPs. It proved to play some role for the size of the effect, but it didn't affect the main pattern of the results. In experiment 2, we focused on the context effect in false sentences using true sentences as fillers and variability of other fillers, and again the between subject factor, this framing variant. And in experiment 3, we used all 8 conditions to look specifically for the truth by polarity interaction. And the framing variant was just collapsed as a variability within the condition. And so most of our hypotheses were confirmed. So we had a larger N400 for less predictable targets. So for weakly versus strongly constraining context, it was across both affirmative and negative sentences similar. There was also a positivity effect for negation. So all the negative sentences show larger positivity, but this is not what I focus on. So I want to just focus on context effects and the N400. In experiment 2, so for false sentences, we had a larger N400 for the violation of stronger prediction, so in strongly constraining rather than in weakly constraining context. And finally, in experiment 3, we had this context by true interaction. So In the strongly constraining context, as expected, there was a larger N400 for false versus true, both sentence polarities, so alike. But in weakly constraining context, the effect was reversed. So this reversal of this effect is what people have observed for negative sentences in prior studies, but never for affirmative sentences. So this was very puzzling for us. There is no clear reason why true sentence continuation would elicit larger N400, especially for affirmative sentences. So we expected a reduction of this effect in the weakly constraining context, but not a complete reversal of the effect. And here we relate to our post-experiment questionnaires. So after all these experiments, people filled out questionnaires where we asked them questions. The first question, most important for us, was whether they used any specific strategy while doing the experiment to facilitate the task. Then in other questions, we asked whether they noticed any irregularities, about framing, and so on. And finally, we asked also how difficult the task was for them. So related to the first question, did you use one or more strategies to answer the question? So this was an open question. People basically could say what they wanted. Nevertheless, the answers fell under few patterns only when you read them through. So, and the most chosen type of answer was that what we call here unique or exceptional object strategy, that people indicated to have focused on the object that stood out, either by being the only one framed or the only one unframed. Then some people said that they focused on chosen objects, irrespectively of whether they were marked or not. Then some people chose on framed or unframed, indicated using varied strategies or non-strategies. So this is like a summary. So you can see that in all of these experiments, it's around 40%, a little bit less in 2B, but this is the largest subgroup of participants that indicated this unique object strategy. And when you think about this strategy, so in the upper panel, it makes you focus on the object C. And in the lower panel, on the object A, irrespective of the framing variant. So for the upper panel, it facilitates the prediction of a false sentence continuation for affirmative sentence and the true one for negative sentence. And this is the weakly constraining context for affirmative sentence and strongly constraining for a negative sentence. And what is the case here? Facilitates the prediction of a false sentence continuation for a negative sentence and a true one for an affirmative sentence, and this context is strongly constraining for affirmative ones and weakly constraining for negative ones. I know it's hard to parse, so I will sum it up. Independent of sentence polarity or framing variant, this strategy facilitates the prediction of a true sentence continuation in a strongly constraining context. So for strongly constraining context, it is beneficial to predict a true sentence continuation. But it kind of works opposite in the weakly constraining context, because it makes you focus on the, so to say, false maker, on what is the only object that is not making the sentence true. So using this strategy should enhance the, if N400 is a marker of meaning-related prediction, it will enhance the N400, this effect for false versus true in the strongly constraining context, so attenuated for the true makers and increase for the false makers in the strongly constraining context, so enhance the effect, the difference. But the strategy will attenuate this difference or reverse it even in the weakly constraining context. And it will also enhance the raw context effect, both for true and false sentences. And this is exactly what we observe. So when we introduce a between subject factor which is the strategy. We basically divide people into a group that uses the strategy and the rest of the participants. We have a highly significant truth by context and strategy interaction. In the strongly constraining context, participants declaring the strategy show a large negativity effect for false relative to true conditions, whereas the effect is significantly smaller, basically almost non-existent for the other participants. And in the weakly constraining context, again, people declaring this the strategy show this large reversal of this N400, and the other participants have a much smaller effect. And it replicates in experiment 1 and 2. So the effect of context, as expected, is much statistically significantly larger for the people who declare this strategy than for the rest of the population, and the same in experiment 2. So now the question arises, of course, what makes people choose this strategy? And why? Why do people decide to focus on those exceptional objects? Is it dependent on their autistic spectrum? Here, maybe not communication or social subscale, but something like attention to detail, working memory of other traits, perhaps. It is, but we haven't found an evidence. So we have compared the two subgroups with respect to this values, and we haven't found a statistically significant difference. So we measured reading span, digit span, autism spectrum quotient questionnaire, and in experiment matrix reasoning test. So it may be hard to always find a clear predictor of a specific processing pattern or interpretation. I think it also is clear from the previous talks. So it's not like there were results, but not like many of these measured traits have failed. So for instance, with autism spectrum people, it's easier to find an effect if you really compare autistic individuals with a neurotypical population, but it is hard to find a correlate within the neurotypical population. Individuals may choose a different strategy. They process a linguistic task in a different manner. And so language processing is not uniform, even if on a surface level it might appear so. So if we didn't do the questionnaires and didn't ask people what they do, we would say, okay, we would try to find the model that relates to negation and explains this reversal. But now we see that this reversal is due to a specific focus and selective attention on certain objects in the context. And it may be artifacts of abstract artificial experiment setting. This can always say when you think about experiments that are highly constrained and involve a task. And thanks to that, allow for more quantitative and results that allow you to dissociate different factors. But it can also occur in more real-life situations, which is just more difficult to measure, and it's open for future research. Thank you. Any comprehension questions? No, I said that the true sentences were target. We had false sentences as fillers, and we had variability of other fillers. And then, because it's a lot of conditions otherwise. And then in experiment 2, we focus on false sentences, context effect for false sentences, and truer fillers, other fillers. And then in experiment 3, we used all of these conditions because we had already established context effect. They did replicate. And for the length of the experiment, we discarded the other fillers that were of different types. So that was the variation. But of course, we didn't have only true sentences in the experiment. That wouldn't work. Yes.